Hello dear students, welcome to this lecture on soil development with special reference to weathering and factors influencing the soil development. In this lecture, we will address some fundamental questions related to the topic, such as what exactly we mean by the soil, how is soil defined, how does soil development take place, what is the process of weathering and what are its different types. Subsequently, we will be talking about which set of factors do influence soil formation and its development. So let's begin with what we mean by soil. Humans as well as rest of the life forms owe their existence directly or indirectly to soils. Soils fundamentally support ecosystems and provide food, fiber, filtration of groundwater and many other economic goods and ecosystem services. Hence, understanding and management of soils is directly linked to the human welfare. Soils are defined differently from different perspectives for different purposes, such as gardening, engineering, agricultural and ecological. But in general terms, soils denote the unconsolidated, thin, variable layer of minerals and organic matter, usually biologically active, that covers most of the Earth's land surface. From an ecological perspective, soils represent dynamic ecological systems providing plants with support, water and nutrients, and sustaining large populations of microbes recycling the materials of life. In other words, soils are complex biogeochemical materials on which plants may grow with distinct structural and biological properties that distinguish them from the rocks and sediments from which they are normally originated. Now, the important question is, how does soil development take place? Dear students, soils are formed from starting materials or parent materials such as consolidated bedrock, loose unconsolidated materials which may be transported and deposited by different factors such as water, wind, etc., or they may be formed from organic residues. Soil development is in fact the outcome of complex interplay between the parent material, the bedrock, which could be of different types, the topography, the climate and the living organisms. It's important to note that an inch of fertile soil develops over hundreds and even thousands of years. The process of soil formation so far is concerned, let me tell you that soil genesis is brought about by a series of complex processes, the most important of which include weathering and organic matter breakdown, then decomposition and humification, then addition and losses, leaching losses of different substances from different layers, followed by translocation and transformation, and then accumulation and finally horizon development. Weathering is basically the process of the breakdown of consolidated rock into less consolidated or unconsolidated matter. Weathering involves both destructive and synthetic processes. Weathering of soil minerals takes place by physical and chemical breakdown of rocks which are unable to support plant life to smaller size materials which are able to support plant life and then subsequently other life forms as well. First, large consolidated rocks are broken down physically into smaller rocks to subsequently yield individual minerals of which they are composed. And if you look at the important factors that influence the phenomenon of weathering, they include climatic conditions. For example, tropical conditions are most ideal. It's important to note that the pathways of weathering may vary in different ecoclimatic conditions. Then physical properties of the rock per se, I mean the particle size, hardness, nature and the degree of cementation or bonding. Then chemical characteristics of the rocks, nature of the chemical bonds in the minerals, crystalline characteristics and so on. We will be talking about these factors in detail at the last when we will be talking about factors influencing the process of soil development overall. But let us first understand what are the types of weathering. Weathering is fundamentally of three basic types: physical weathering, chemical weathering and biological weathering. It is important to note that depending upon the composition of rocks or the bed or parent material, some rocks are very resistant and others are susceptible to weathering. So for the first type, that is physical weathering is concerned, physical weathering may involve mechanical disintegration which results in decrease in the size of rock and its constituent minerals without appreciably affecting their composition. It can generally be caused by factors such as temperature, I mean through differential expansion of minerals, what temperature causes, frost action and exfoliation. Then it can be also caused by erosion and deposition by agencies such as water, ice and wind, and plants and animals also do influence this physical weathering. When mechanical weathering takes place, the rock crumbles off under the influence of temperature variations, and cracks in hard rocks increase in numbers and size as well due to the freezing of water, leading to expansion and application of pressure alternated with thawing of ice. In these cracks, bit by bit, a raw soil is formed slowly, in which pioneer plants can survive, and then plant shoots further penetrate in these rocks or their crevices or cracks and enhance on their turn the fragmentation process. When plants die away, I mean the plants which now grow on this system, when they die away, their remains are added to the already present soil particles. When nutrients are liberated from these remains, they boost the microbiological development. Organic matter is further demineralized, and when water passes, it drains some of the components out to deeper layers. The other type is the chemical weathering. During chemical weathering, simultaneously rock fragments and minerals are acted upon by chemical forces and changed to new minerals, either by minor modifications, I mean alterations, or by complete chemical change. Thus, in physical weathering, rock breaks down but stays almost the same what it is made of. The chemical weathering still breaks down the rocks and may change what it is made of. For instance, a hard material may change to a soft material after chemical weathering. Usually, primary minerals, for example feldspars and micas, are dissolved and they form secondary minerals, for example silicate clays. And you must be knowing silicate clays result from the alteration or decomposition and recombination processes. And on the other hand, iron and aluminum oxide clays are far more resistant end products of weathering. Chemical weathering of soil minerals is accomplished by processes such as hydrolysis, which yields hydrogen ion and hydroxyl ion, OH ion from water, hydration, that means taking on water, carbonation, which yields carbonic acid, then organic acids, which are very important and effective because they chelate because of their chelating action. Then oxidation and reduction, that means losing or gaining of electrons. These are some important factors which influence the chemical weathering. And as a result of these factors, soluble products of weathering such as sodium, silicon, calcium and so on, they leach away, while as less soluble products like iron oxides, they may stay behind. Water and its dissolved salts and acids are perhaps the most pervasive factors in weathering of minerals. Water in fact enhances degradation, alteration and resynthesis of minerals through hydrolysis, hydration and dissolution. Conversion of microcline, which is a potassium containing feldspar, to hydrated aluminium oxide best exemplifies hydrolysis, dissolution as well as hydration. Because if you look at this conversion of microcline to hydrated aluminum oxide from solid microcline, when water, as the action of water, one solid form is there and then through different intermediate forms ultimately you get aluminum oxide which is hydrated, which takes on water. Then the third type of weathering is the biological weathering. Plants, animals and microbes may facilitate chemical weathering through release of acidic compounds, and such facilitation constitutes what we call as biological weathering. Different organisms release chelating compounds, that is organic acids, siderophores and so on, and acidifying molecules, that is protons, organic acids etc., so as to break down aluminium and iron containing compounds in the soils beneath them. Lichens, for that matter, lichens and mycorrhizas have a special role in biological weathering. Lichens grow on rocks to increase chemical weathering rates, and the mycorrhizas are associated with the plant root system for releasing inorganic nutrients from hard minerals such as apatite or biotite, which are otherwise inaccessible to the plants per se. Biological weathering mainly involves decomposition and humification, which is influenced by the soil microbial communities. And decomposition, in fact, you must be knowing, is the breakdown of plant derived material into its simpler organic constituents. This is accomplished by enzymes, earthworms, mites and other organisms. And humification is the breakdown of plant remains leading to the formation of different types of humus. It is probably the most important and complex biological processes taking place in the soils. Dear students, if you look at these factors, soil formation is defined in terms of the physical, chemical and biological changes in the weathered material. And if you look at the important changes, these include addition of organic matter, losses of materials due to leaching, then translocation of clays and dissolved materials from one horizon to the other, transformation within horizons, and let me remind you, horizons, by horizons or layers, what we mean is they are distinct layers which are present in a soil profile. In fact, horizons result from soil formation, and the distinct horizontal layers present in a vertical section of a well developed soil comprises what you call as soil profile. And so for this development of the soil profile is concerned, every well developed undisturbed soil has its own distinct profile characteristics which are depictive of its composition, legacy and properties. Conventionally, 5 major horizons are recognized, which are designated by uppercase letters O, A, E, B and C. In addition to these, subordinate layers or distinctions within the master horizons are distinguished as well, which are designated by lowercase letters. And if you look at these as typical soil profile, The upper O horizon in fact comprises the uppermost organic horizon, which is well developed in forest areas and almost absent in the grassland systems. This horizon is followed by A horizon, which is the topmost mineral horizon that tends to impart darker color than that of the lower horizons. It is followed by E horizon, which indicates the zone of maximum leaching, illuviation with E of clay, iron and aluminum oxides, which leave resistant minerals such as quartz in the sand and silt size range behind. This horizon is followed by B horizon, which represents the layer of illuvation, which starts with I, that is leaching in of materials from above and even below, and is sometimes incorrectly referred to as, this horizon is incorrectly referred to as subsoil, which is followed by C horizon. C horizon in fact is the lower unconsolidated material outside the zone of major biological activity underlying the soil and may or may not be the same as parent material from which the soil is formed. And finally, the lowermost layer is recognized sometimes as R layer, which is the underlying consolidated rock with little evidence of weathering. As I said, besides these master horizons, there are a number of transition horizons and subordinate distinctions as well. Now, the students, let us focus our attention to the important aspect of this lecture, that is factors influencing the soil formation. Soil development or formation is influenced by a number of factors, but the major factors include: number 1, parent material, its nature and composition, followed by number 2, climate, especially which includes temperature and precipitation, followed by number 3, biota or living organisms, particularly native vegetation, microbes and animals and even human beings growing there. Then 4th, site topography is an important factor, followed by time that parent materials are subjected to during soil formation. Looking at these factors, first important factor is the parent material. The nature of parent material significantly influences soil characteristics. Weathering of bedrocks can lead to formation of residual soils on site, or parent materials can sometimes be transported elsewhere by various agencies for further soil development, and transported parent materials are far more extensive than residual soils or residual materials. And on the basis of the agency of transport, soils can be grouped into different types, such as alluvial, which are water deposited soils, aeolian soils, which are wind deposited soils, glacial soils, which are ice deposited soils, and colluvium or colluvial soils, which are gravity deposited soils. Parent material has a direct influence on soil development through its influence on initial soil texture, the particle size and distribution, its nutrient concentration, especially other than nitrogen content, and rate of weathering. Moreover, the parent material can influence the soil in terms of color, texture, structure, mineral composition and permeability or drainage. It is especially important in early soil development than in older soils. For instance, limestone richness in parent materials delays the development of acidity, and such pH alterations have profound impact on development of other characteristics. Soil development is also linked to the landforms, and different parent materials often have distinct landforms. Erosion tends to level off parent rocks and leaves a layer of soil behind. This landform is called usually a pediment. Now, the second important factor is the climate. Climate has a profound influence on soil formation through its impact on nature of weathering, including physical, chemical and biological weathering. And in fact, climate governs the rate and type of soil formation and is also the main determinant of vegetation distribution. Soil climate has two major components: moisture, the precipitation, and temperature, which influence evaporation. When precipitation exceeds evaporation, leaching of soil will occur. Temperature determines the rate of reactions, chemical and biological decay, and so through this, temperature has an important influence on weathering and humidification. Third important way is climate also influences natural vegetation and other living organisms, and variation in soil profile development and characteristics in different areas with variable precipitation and temperature regimes are direct evidences of the climatic influence. Relatively modest profile development characteristics of cold areas in comparison to deep weathered profiles of humid tropic regions further substantiate the influence of climate on soil formation. Dear students, climate influences physical weathering through its impact on erosion, which is caused mainly by precipitation, colluviation, that means the downslope movement caused by water, which is stronger in warm regions than in cold regions, then of course freezing, thawing and frost cracking, etc. Climate also significantly influences the chemical weathering. For instance, rainfall rate affects the extent of dissolution and leaching. This is substantiated by the fact that accumulation of carbonates and salts in arid soils, the calcareous or alkaline soils, is a result of low water availability. For example, dissolved calcium and sulfate precipitate to form calcium sulfate, what you call as gypsum. Besides, climate also influences organic matter indirectly via plant productivity and decomposition. So, after parent material and climate, biota is the third important factor which influences soil development. Biota, the living organisms, influence the soil development and profile differentiation through rate and nature of organic matter inputs and accumulation, then profile mixing, nutrient cycling, important soil microbes and mycorrhizas and nitrogen fixing microorganisms have an important role in this nutrient cycling, then structural stability. The importance of biota in soil formation is reflected by what we call as islands of fertility in deserts caused by far separated plants or vegetation groups. Tree roots pierce and thereby break down the rocks. That is also a biotic effect. Then action of burrowing animals, especially earthworms, is pretty evident. Then microorganisms, extremely important, which are in the process of soil development. And lichens, as I said earlier on as well, symbiotic relationship between algae and fungi comprise the lichens. They are the first to colonize the rocks, the barren rocks, and set the process of soil development in. And vegetation cover in fact reduces natural soil erosion rates, thereby slowing down the rate of mineral surface removal as well. Dear students, a comparison of properties of soils formed under grassland and forest vegetation clearly depict the influence of vegetation. As you can see, the soils of grasslands are richer in organic matter content, which imparts darker color, higher moisture and cation holding capacity and structural stability in them in comparison to forest soils, which if you look at the coniferous forest vegetation, it tends to be low in metallic cations such as calcium, magnesium and potassium, and also it encourages development of acidity. And one more factor is the topography, that means the configuration of the land surface, which describes or is described in terms of variation in elevation, slope, aspect, etc. it significantly enhances or delays the work of climatic forces and modifies the vegetation effects. The important parameters influenced by topography are drainage, precipitation, erosion, alluvial and colluvial activity. Relief, which is a related term which includes landforms and topography together, is a dynamic system which influences soil development in terms of soil profile thickness. As the angle of slope increases, so does increase the erosion hazard, effect on climate, an important soil forming factor. Lastly, soil formation is influenced by a number of factors, the major important factors of which include the parent material, climate, living organisms, site topography and time that parent materials are subjected to soil formation. In fact, soil development is the outcome of complex interplay between parent material, the topography, the climate and the other living organisms. So with this note, I take your leave as of now until we meet in the next lecture. Goodbye.